Hello and welcome to video 5 in this series of 6 videos. My name's Andrew and I'm going to take you through this particular video. Let's have a look at the contents. This video is mainly going to focus on for loops, nested for loops and iterations, which are critical in a lot of different programs and options within the coding language. We will also look at one of the challenges as well for the Bebras. So let's begin. So topic 6 is all about nested for loops. And if you've never heard of this before, think of a bird's nest where they just make little sticks and they put them inside other sticks and this reinforces the nest. And this is exactly what happens within a nested for loop. So as we can see here in the example, we have what we call the outer loop, and that is this top one here. And then indented inside, we have the inner loop, which appears here. Now, as you can imagine, what happens here is the outer loop will run one loop. The inner loop will run round all the number of ranges that it has. In this case, it's going to be 2. So it's just going to run around twice from 0 to 1. Then once this is run from 0 to 1, it will finish that loop and it will come back to the outer loop, which will now go to 2. And then it will come back to the inner loop and that will run 0, 1 again. And this procedure continues until the outer loop has finished, which in this case will be 0 to 2 because we have 3 as a range. And it's always 1 before the range. These are very useful for things like 2 dimensions, particularly in lists and matrices, which we were going to see later on. So let's have a little look in a bit more detail in what these nested loops look like. Now, the actual body of the loop, it's a little bit complicated here because what we can see is that this part here is actually inside and is the body of the outer loop. So all that is going to run, in this case, from 1 to 10, because we always do 1 less than the range gives us. It's then going to jump into this inner loop over here, and that's going to run again from 1 to 10. And the only way to really understand this is to try to put a print in it so that you can see what's actually happening in every single iteration of the loop of both outer loop and inner loop. So let's go straight to an activity, try to understand what's going on here. What I want you to do is pause the video now, have a quick think about what would the output be of this code without actually executing it. So just to give you a guide, this top one is going to be 0 to 2. This middle one is going to be 0 to 1. And every time it prints out I equals the outer loop and J equals the inner loop. And here is a solution, as can be expected. Because the inner loop has 0 and 1, then that essentially is going to loop around twice. And we can see here that it loops around twice. So for each iteration of the outer loop, which is this one, the loop runs twice. And that would run 3 times if we change this number here to 3. And we can see the actual numbers changing as the J changes from 0 to 1, 0 to 1, 0 to 1. And that's run twice. So therefore the outer loop will remain in that position for 2 iterations. Another activity, can you try to write code that prints each element individually? So we start off with a list. This is actually a 2D list because we can see multiple brackets. Essentially what it is a 1D here, a 1D here, another 1D here. And your job is to pause the video, write a program using nested fors to try to produce this as an output. And here is the solution. First of all, we create the solution, the list, sorry, which we can see here, 1 to 3, and so on. And then we start the actual for loop. Now, the outer for loop is going to run for the length of the list. And that's why we're going to print all the numbers. And the inner for loop is going to grab the item of the sublist. And then it's going to print them out. So basically what it's going to do is going to print out 1, 2, 3. Then it's going to print out 4, 5, 6. And then it's going to print out 7, 8, 9. And that will produce this output here, which is what is required. Let's have a look now at iterations. What are iterations? How do we iterate over an element, so to speak? Well, the first method is very simply setting up an outer loop and an inner loop. And here we have the row and the element. So we have a list, and we make a variable which is called row, and that's going to run around this list. Then we grab each element in that row, because remember this is now two-dimensional. It's going to look something like this, where you have values inside here, like this. And then it's going to print every single element. So what this will do is it will iterate over every single element in the 2D array that you have. Method 2. This one's a little bit more complicated, but it's also quite useful depending on what you're going to need and what results you're going to have. But what this does, it essentially does the same thing, but it's using, instead of just grabbing the basic for variable row inside list, it's actually grabbing the range. It's making a range from the length of the list. So if I have 5 numbers in the list, let's say 2, 4, 6, 8, 10, then the length of that list is going to be 5. So it's going to run 0 to 4. And as you can see, the print will actually print out the I value, which is going to be 0, and then it's going to run through the list in the middle. And that is going to be the inner loop, which is essentially acting as the indices so that we can grab each element in the 2D array. I really do advise you to play around with this, make a couple of lists, see what happens, because they're quite difficult to understand until you actually practice with these. Okay, let's have a look now at linear search. What is linear search? Well, in this case, I would need it. Why? Because I have a 2D list. You can see it here underneath. And I want to do a search in that list. I want to find out if the number 60 is inside this list. If it is, give me a true, which is basically equal to 1. If it's not, give me a false, which is equal to 0. Now, this is definitely the most complicated program we've seen so far, but we need to go into it, and the reason it looks more complicated is because it actually has a function. And functions are very, very useful. Hopefully from after this session, every program you write is going to have a function in it. So we're going to begin over here at the starting point, which is making our list, our 2D list. You can see the multiple brackets, 1, 2. So that must be a 2D list. Then we make our function. I know it's a function because it has def at the beginning. It has a name here. And then it has the values that I'm passing to it, which is the actual list. And then obviously the target is the number that we're looking for, which in this case is going to be 60. And if we look down at the bottom of the code, we can see my target is indeed 60. I pass it over here. I call the function. It passed the list and the target way over here to the function. And then that function can operate on the list and that target. So we have a nested for loop, which is going to be running around the 2D list. And if the list is equal to the target, so as it starts cycling through all these numbers, bang, 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 it's going to eventually come across 60, which is in the middle. So therefore, it's going to say element found at position, and then it's going to give you the row and the column position of that value. And it's going to return true. So the value result in this case will be true. And it's going to print to the screen the element found at position, row, column. This is a very nice program to run. So do make sure that you type this in yourself and experiment with this. Try different values, change the target value. It's a very good learning process, this. Not only for lists, but for nested for loops and also for functions. Okay, activity time. Write a piece of code to print out all 3 lists together in the same list. Again, pause the video, have a go at doing this in Python and see what you can produce. Here's a solution. It's really quite a simple one in this case. We initialize and declare a list, an empty list. We create 3 lists, which you can see up here. And then we simply append them to our list that we created at the beginning. And this will then be one list of 2 dimensions with all these values in it. Another activity. Let's say I give you a 2D list. I want you to pause the video, write a program that calculates this and prints the sum of all the elements. Now, this is a really nice program, which kind of is similar to the ones we did earlier, where we cycle through every element, but this time we have an extra variable where we're going to keep track of the sum. Okay, pause the video. I'm going to show you the solutions. And here it is. Here's the 2D list we created. You can see the multiple brackets. There's our first one, our second one, and our third one. Okay, how do I do this? Really quite simple. What I'm going to do is I'm going to have my nested for loop because I'm dealing with a 2D list. I set the variable row sum equals to 0. That is going to be my total. That essentially is going to be my total at the end. And the row sum is simply going to plus and equal. This is shorthand, which basically means row sum equals row sum plus num. And num is the element that we grab from the row from the outer loop. So that essentially is going to be each element of each one of these, 1, 2, 3, 4, 5. And what this will simply do, it was going to add all these numbers together and print out the final sum. Now, just as an added extra, what would you need to change to get the total sum of all rows? So the way this is designed is every time it goes around the inner loop, this gets reset again to 0. So the output is going to be 6, 15, 24. Now pause the video again, have a little think. How are you going to do this? And the solution is dead simple. We're going to take this one out and put it at the beginning of the code. That way it's 0 when it goes into the nested for loop, and it's not reset after each iteration, after each row is finished, and it continues summing up all 9 values. Inner and outer loops. Let's have a look now at a slightly tricky case of where we can use nested loops. And this is quite often used actually in IQ tests and in challenges, in programs like that, because you really need to think outside the box and really focus on how these work, every line of the code. And what really helps if you do a tracer program and you trace the steps of the program. What that means simply is every iteration of the loop, you print out what the value is. And that's called a trace program. So let's have a look here. What we want to try to start doing now is to produce dynamic and flexible patterns using inner and outer loops. So let's have a look. Let's go straight to an activity. This is a classic activity, this one. What we want to do here is we want to print a star, and that star is going to increase in size, essentially like a triangle, getting bigger and bigger and bigger. Now, we're going to begin with just n equals 5. So see if you can do this. And I'm going to give you a tip here to get you started. And if you want to print multiple stars on the same line without going to the next line, then you can use this at the end of the star. And what that does, that holds it. It prevents the new line from the print being shown. So basically, you want to keep on the same line until you've printed out however many stars you want, and then you're going to jump off to the next line. This is definitely the hardest challenge for you to do on your own. So can I suggest that you pause the video and check out the solution shortly. Here is a solution. It's very, very simply making a for loop, a nested for loop. In this case, it's going to go 1 to 5 because n equals 5. I want 5 stars. It's then going to print out the star. It's going to start with 1. Then as it goes to the next one, it's going to give me 2. As it goes to the next one, it's going to give me 3. And this is going to continue down for however many I have here. So try not to add a 0 at the end, because that's then going to become quite a large triangle of stars. Another activity to keep you going. Instead of printing stars, I want you to print numbers this time. Essentially what it is, it's another number inside a list. So to give you a hint here, you're going to make a list. And as the program runs down, you're going to keep adding a number to that list, which is going to be the for loop that is cycling around with its iterations. So stop the video, have a go, see how it works out for you. Here's the solution. We simply set an empty list here, and we set an outer range from 1 to 5. We then set the inner range, which is going to go from 1 to I plus 1. So whatever the I value is, it's going to give 1 more than that. Remember that this is needed because when you use a range, it always gives you -1, whatever this value is. Now, this is quite a clever little program because all it does is it creates a row, which is an empty list in this case, and it just simply appends the value of j to that row. And that will eventually print out all of the numbers depending on how many you have. Okay, so that's kind of a warm-up to all the sorts of things we've been talking about. Now we're going to move on to the most difficult challenge that we've seen in this series of videos. And this is going to require a number of things, such as a function. We're going to need the for loops with a range. And we're going to need a number of if statements to check specific values. So let me introduce you to this challenge. This is from Pathfinders, and it's called Happy Ultra Runners. Now, it's quite complicated, this, but I'm going to simplify it as always at the end. So let's just have a look at what it says first of all. We are in a season of running, which is called Ultra Run. And every person who participates in this competition has 5 races. And the runners are awarded at points which are based on a number of factors, like how hilly the area was, the position they finished in, a number of factors. every runner aims to improve their performance. So every time they run in one of these races, they want to get a little bit quicker each time. So therefore, a happy runner is one that improves throughout the season. So your job is to write a program that outputs the number of happy runners, that means a single integer, at the end of the season from the data provided. So in simple terms, what that means is we want to try to find that each one of the numbers that are entered in the 5 races is going to be an increase on the previous one. So let's look at some restrictions that we have. First of all, the first line must be an integer, and this represents the number of runners. So this can be 2 runners, it can be 5 runners, it can be 10 runners, or whatever. Then every line after that will contain however many runners there are times the 5 races. So if I choose 2 runners, then I'm looking to put in some numbers like this. That would be my first number entered. That would be the 5 races from my first guy. And then I'm going to put 5 more times for my second guy. And that would be it. That would then produce an output, which in this case would actually be 1. So let's have a look at the example. In the example, we choose 4. And we can see the numbers, 50, 50, 70, 80, 100, and so on. And if you look at these very carefully, you'll notice that only one of them, which is this one, actually has increasing times. In other words, increasing points. We shouldn't call them times. They're actually points that the competitor wins. And all the other ones, they're either the same, they go down, and they're not all increasing. So therefore, the output of this program will be 1. Okay, so let's get over to the program and find out how we're going to do this. Go to Blockly and start writing some code. Okay, first thing I'm going to do is make a function. And that function is going to be called whatever we want, but I'm just going to call it is consecutive sequence. And in that sequence, I'm going to pass to it a list. Now, remember what we want to do in this function. We want to try to produce a program that will find out if every number from the 5 numbers is increasing. In other words, if the number previous is smaller than the new number. So there's a few ways of doing this, and let's just have a look at the simplest way. Is bigger. This is something called a flag. I use this, and many other people use this an awful lot in programming. And it's a flag because it keeps track of something for us in the code. So let's start our for loop. Let's give it an index, my favorite word. I'm going to make a range, and I'm going to use the length of the list minus 1. Okay, that's my for loop. Now I'm going to indent because the if is going to be inside that for loop. I'm now going to grab the list, which has been passed, which is going to be passed to it in the code a little bit later on. And we're going to look at the index plus 1. And I want to make sure that this value, because it's plus 1, this is less than or equal to the original index value that I have. And this is simply the heart of the program. This is where it checks if my next number is greater than my previous number. That's all this does. And if it is, then I'm going to say, well, if it isn't in this case, I'm going to say it's false. So what happens here is that if any of the numbers are the same, or if they're smaller than the previous one, then we're going to break out of the code. Otherwise, we're just going to continue. So let's go back to here, and that's going to give me a return is bigger. Okay. So that is what my program is going, my function is going to do. It's going to tell me, is it bigger than the previous one or not? Now I'm going to go to my normal code, and I'm going to take the values from the user. So let's do an input. Again, I keep saying this every time, but you don't need to add anything here if you don't want. I'm going to add something. So enter the number of runners. Let's set a variable equal to 0. And then let's begin our for loop, because we're now going to run it nums times, and we're going to grab in all the results for the runners. So I'm going to use a range as usual, and that range is going to be however many times I have a runners. So I'll start with the for loop, then I'm going to go input list. So this is going to grab all my numbers now. Now this code is essentially another for loop, but I'm just going to show you now how you can reduce the length of your code by having it all on one line. And this is a pretty clever piece of code. And I'm going to input, and I'm going to split with a space each one of those. So this simple thing here is the same as having a for loop like this, but I've got it all on one line. If you wish to separate it out and make a normal for loop looking like this, then you can do, it will do exactly the same thing. Okay, so now I've taken in my values. I want to find out if each one of these numbers is actually true or false. Is it bigger or not? So if the consecutive sequence of the input list that I give it, if it's true, that is, if it's bigger than the previous one, then we're going to grab the variable which we made here, and we're going to use shorthand, plus equals, and we're going to print, we're going to make it a counter. We're going to add one to it. So basically, if we get here, and it's made a typo there, if we get here, then what happens is that the previous number is smaller than my next number. In other words, my next number is bigger than the previous number, and therefore the runner has improved his number of scores. And so therefore we add another one to this. But we don't need to have that there. It just is plus equals 1. That's the whole idea of shorthand. And then we're going to print out the results. So that's just going to, I mean, you can add an F string here. You can say your results is this. I'm just going to keep it super simple, like so. And that looks to be okay to me. Let's give it a run. See if anything is wrong. Oh, I've spelt it wrong. It's if. There you go. Okay. Input list. That looks good. Oh, we have an error on line 4. What's wrong with this? On line 4. Oh, I think I've missed a bracket, have I here? For index in range, len, list, yes, -1. Ah, I haven't put I always forget those, the colons at the end. There you go. And they're the blocks for this. Quite a few blocks for this. It's quite complicated, this one. But if you break it down and go through this one at a time, it's not that bad. Let's try it out. So I'm going to put 3 runners in. And let's put 20, 30, 40, 50, 60. So that's definitely increasing each time. Now let's make it decrease. Or put the same numbers in. And the last one, let's make it increase as well. And that should now output, yes, 2 numbers, which is correct, because I had 2 out of the 3 which were increasing. So a couple of improvements you could make to this. Let me just show you the whole blocks again. So that's the top block, which is the function define. That is the bottom blocks, which is essentially the main part of the code running, which is calling this function up here. And that's the basic layout that we do in programming. We always make functions from this. So a couple of improvements you can make here. If you don't like having all this in one line, then you can break that down into the normal 2 or 3 lines, which will be needed for the for loop. We can add some more text here for the input to say like enter race number 1, enter racer number 2. And you could also have an F string here at the end, which will say your final result is 3 runners were actually improved in all of the 5 races. And that's basically the code. So that's great. Let's go back to our presentation and I'll show you the code here. In this one, I've added a few more comments for as you can see here, how many runners are there? In the input, I've put an F string, which actually tells you, please enter runner 1 with a little bit more information, like give me a space because I'm going to split. Okay, let's go back to the code that we made before for the challenge. And as usual in all the videos, we're going to try this in Bebras and see if it is correct. So let's grab the code, go over to Bebras, Happy Ultra Runners, paste the code in. We need to get rid of all comments. And let's submit the code. And we've got a full score solution. And there you go, everything is passed. Great. So thank you for joining me today. We have another successful program under our belt, and have a great day, and I'll see you next time.